name is Akash Murthy. I'm from India, but I've been staying here in Dublin, Ireland for the past few years now. And about a couple of months ago, when I actually pitched this topic as a workshop for ADC, the title wasn't all. The title was sort of like a no-brainer for me at that moment, because I wanted to talk about continuous integration, probably in the realms of Jenkins as a build server, and probably how to move that build process and the build server into the cloud. So introduction to CI setup in the cloud seemed like an obvious title. But then a couple of weeks back, we had an induction session where we were, there was a workshop of sort that they talked about how to present, how to conduct the workshop, the best practices and all that. And during that time, they gave me this placard that you see in front of you. And they asked us to put the placard in front of all of the other slides. And so I said, yeah, sure, yeah, this looks good. It's very visually intriguing. But then as soon as I read the title, it sort of struck me. I think I might have messed up here, right? Because when I read the title, is it in the cloud or on the cloud? I wondered. Both of them kind of make grammatical sense, right? So a service running in the cloud, service running on the cloud. But what do I know, right? I'm not a native English speaker. But then again, in English, it's a weird language. You have rules that defy the rule. So I went and did a little bit of digging to see what the actual answer to this question is. So I came across this Stack Exchange, in fact, article where they have occurrences, the number of occurrences of a particular phrase in Google. So it's in the cloud or on the cloud. So statistically speaking, it's in the cloud because it occurs more times than on the cloud. So it's like, oof, I was right all along then. But then again, I came across another article which said something like this. It said, the difference between in the cloud and on the cloud is that using a service in the cloud means that the cloud provider is actually responsible for maintaining the service. And if it's on the cloud, then the user is responsible for maintaining the service itself. So the example that they gave here is like MySQL, right? So that's a database. If you host it on an instance that you control yourself, that means it's on the cloud. But if you're accessing MySQL as a service from a provider, then it's in the cloud. So I was wrong all along then. So it's supposed to be on the cloud. So based on that segue, please welcome to my talk on CI setup on the cloud. It's my first talk on ADC, and I'm really privileged and honored to be here. Might be a little nervous, but please bear with me on that. So what do I do? I work, as Josh pointed out, I work as an audio programmer for the Audio Programmer. You might have come across the Audio Programmer. You might have seen a few videos on YouTube. You might have interacted with the amazing and vibrant community on the Audio Programmer in Discord. You might have seen the recruitment wing of it. But there is also a development wing in the Audio Programmer where we consult and develop audio applications and plugins and solutions for other indie development houses or producers. And my responsibility there is to write audio applications, but also do a little bit of infrastructure support and quality control, stuff along those lines. And that's where I was sort of tasked to do a generic pipeline of sort, so that all of the plugins that are being actively developed could go run through the pipeline, so we can eliminate a lot of redundancy, and the build process can be sort of consolidated in one place, and not all the developers need to know exactly how to build and how to sign and notarize and all these things that are it's hard for information to be shared and hard for certificates to be shared securely as well. And I hope to present whatever I've done there over here, and I hope you can follow along as well. So I'm going to try and take it at a slower pace, but let's see how it goes. And before all this, I used to work as a full stack developer in the financial services, writing web applications essentially. I used to work mainly as a backend developer, writing Golang and Java applications. And I also used to work a little bit in the front end using Angular, React, and all that. But what I noticed there in the realm of web application development is that the CI, the process of CI/CD, is quite mature. It has to be, right? So in the realm of web applications, scalability is an important concern. So the applications, and especially enterprise web applications, get a lot of traffic. So they need to be able to scale when the demand is high and scale down when the demand is low. And if you want performant web applications, you need to throw a lot of resources at it. Right? But resources can be quite expensive. So if it's on the cloud, you for smaller instances, you don't have to pay quite a lot. But if you want beefy, chunky instances, you have to pay up essentially. And you don't want to pay for power when you don't need it. So scalability comes into play when the hit rate is quite high, when there's a lot of traffic and throughput coming through. You should have the ability to scale up. And when the traffic is not so high, and you should have the ability to scale down. So it's auto scaling. And they have dedicated engineers there whose skill levels are way past mine, right? They're called site reliability engineers, whose primary purpose is to write pipelines and write infrastructure as code. So all of the infrastructure that they have is consolidated into source control, so they can bring up the infrastructure on demand and tear it down whenever they don't need it. And that's where some of the concepts that I'm talking about today come from. And also, you need high availability. So we kind of strive to achieve 100% availability, though it's not always possible. Availability, as in when you hit a web server, when you hit a URL, it needs to give you some result. It can't say 503, for instance. And enterprise web applications, if they're going down for an hour or so, would cost the company quite a lot of money. So it needs to be in a state that when you push code, you have to have like an airtight process where if something's wrong, it needs to be rejected and rolled back. And even when we're pushing code to production, we have to make sure that there's some sort of blue-green deployment where an earlier version of the service is still running and fully functional, and a new one comes up and the older one goes down. So all of this is quite sophisticated to achieve by hand. And so they write pipelines to do and automate all of these tasks. But in the realm of audio development, for instance, CD is not too much of a problem. Deployment is not too much of a problem because, let's say you build an application, you still want it to be tested. You don't want it to be beta tested or something like that. You don't want it to be pushed directly to a server where it's accessible for everyone. But maybe you do. There's a lot of flexibility in what you want to do. But then again, I see that CI/CD pipelines in the realm of audio development is quite localized to companies which are well established. They're not really followed by individual developers or small indie firms. So I want to try and break that stigma and try and make it easy and more accessible for people. So what is this workshop about? So we're going to be talking about CI/CD in general and CI/CD in the realm of audio development. We're going to use Jenkins as a CI build tool for this, and we'll talk about why I choose Jenkins. You may choose something else, and that's perfectly fine. We'll talk about alternatives and the motivation for actually using Jenkins for this. We'll talk about the general workflow overview of what we're going to be building. And we'll talk about the concept of pipeline as code, where you take the configuration of the pipeline and you check it in alongside your code in version control. And we'll just generally talk about moving the CI server to the cloud and why we even want to even consider it, because it seems like it's like a fad at the moment, like everything in the cloud, or on the cloud. Sorry. So the advantages and pitfalls for using the cloud at all in this case. We'll explore some of those ideas. So if you didn't know already, it's a 3-hour workshop. Yeah, I know it's huge. I hope you don't mind me rambling along. So it's split up into three sections. The first, each section is about 50 minutes in length. And there's about 10 minutes break in between. And you can stop me anytime. Well, you can post questions on the chat. And the workshop will essentially be just general information about the motivations for CI/CD. What are the alternatives to Jenkins? What kind of flavors do CI tools come in? And why I choose Jenkins in the first place. And we'll check out the code that we'll be using in this workshop. And we'll go ahead and install Jenkins on our local machine. We'll set it up to be used. On the next part of the talk, in part B, we'll go through the basics of Jenkins. We'll set up a freestyle job in Jenkins. And then we'll actually explore the concept of pipeline as code, as I mentioned. And we will script a pipeline using Groovy as a language. And then we'll set up a pipeline job so that in Jenkins, so that our whatever changes that we push to version control gets picked up and built. And part A and part B will be mostly interactive, as I mentioned. So I'll go through the steps required kind of slowly on my end. I'm presenting on a Windows machine, but I can also remote into a Mac machine to show you if things differ over there. So I'll go at a pace, a slightly constrained pace, and hopefully you can follow along with me. But if you run into errors, it's going to be really difficult to troubleshoot all of them. So we'll see what we can do. But part C of the talk is going to be about the cloud. Over here, I don't expect you to follow along with me. You could, at some point of time, if you have an AWS account with you. Most of the things that I'll be talking about here will be cloud agnostic, meaning that you can use any cloud provider you want. But I'm just going to use a concrete example of AWS here. So cloud services, what are they, and what kind of cloud services do we need to use to get CI in the cloud, on the cloud? Is it even worth exploring this option? Is it worth the cost? And we'll explore a few services on AWS. And to do all of this, there's a master-slave configuration which Jenkins offers. Or if you want to tone it down a little, it's sort of controller agent configuration. And this is what makes it really powerful as well. And we can explore the concept of on-demand power. Like we can scale down build servers and scale up build servers when the demand rises or falls. Right. Let's talk a little bit about why continuous integration even. It's like any other software engineering discipline, like agile or test-driven development, or anything like that. It's just a discipline of engineering, or rather a process, I would say. If you have a task that you don't need to think about to do, if there's a task that just needs to happen and you can have a script that can do it, if you can automate something in your workflow, then there is every likelihood that it should be in a continuous integration and deployment pipeline. So anything that is an automatable task or a routine task that doesn't require a lot of brain power could be delegated and moved to a continuous integration workflow. Well, why, right? So why would we want to do this? So it gives us quite a lot of feedback really quickly. So let's say a developer came in and there are a few people working on a code base, and a lot of the time, constraints of time or so on, you check in code, and another person comes in later along the line, and they find that it's broken, and the other developer is not to be seen. And so you want feedback as to whether your code that's been checked into to version control actually builds and it passes all the tests. So continuous integration gives you a way of getting fast feedback from pushing code into version control. And then the other advantage is it isolates the developer machine from dependencies. Dependencies could be multi-module projects, for example. The developer doesn't have to check out all of the modules for it to build the entire application. He can just work on a certain module and push it into his version control. And if everything's fine, the build server will be able to will have an overall systems view of the application, and it'll have all of the necessary resources to build it. So the developer doesn't need to have everything on his machine, on his or her machine. And other dependencies like certificates or licenses, for example, for code signing and notarization, or for example, one of these, the iLocks. So not all developers would working on a code base would have these on their machines. So you can have a build. You can consolidate all of these dependencies within a build server, and the build server can typically be responsible for doing all of these all of these routine tasks. And finally, it's time efficient. Right? So you don't want you want to try and optimize how valuable your time is. You want to try and optimize the workflow such that you don't waste time on like routine tasks that you don't really want to keep doing every time you make a new build. So I've been going on about continuous integration quite a lot, but you usually hear the term CI/CD, right? So what about deployment? I'm not really going to talk too much about deployment, though the pipeline that we're going to build will contain a little bit of deployment steps as well. It's just because it really depends on the application and depends on the workflow that you want. What is deployment, right? So deployment will be making something available to an end user, to another group of people, essentially. So in our case, what can be deployed? So you can deploy artifacts to certain destinations. So you can either deploy the artifacts, the build artifacts, to the final destination, which could be like a server that sources this out to people, or it could be like a shared storage like Dropbox or Slack or Google Cloud Storage, for example, where testers and beta testers and other users could have access to it. And then you probably after the final release is done, you probably would want to update the changelog or documentation in a particular site. You could use that as a different job. And you can have notifications that run at the end of each build to notify testers or end users that something is out. You can test it now, or you can use this now, or you can try and update this now. It could be notifications, could be, like Slack notifications, email notifications, text message, fax. It doesn't matter. If there's a service out there that can do it, if there's an API exposed that can do it, you can call that API and get that done. Right. So we'll just talk generally about like the CI tools that are available. Like I said, CI is a process, and there are loads of tools that can help you accomplish this process. So you have tools like Jenkins and GitHub Actions, Circle CI, Travis CI, Bamboos, GitLab CI, Azure Pipelines. There are plenty more here that I haven't even listed. There are plenty. There are loads of tools available. So you really need to get an understanding of what these tools. It's very hard to get an understanding of what these tools offer because there are so many of them. There are so many choices out there. But we'll try to break this down a little more, just more granularly into sections and separate them out as why you would want to choose one over another. And there are plenty of resources out there for this. And there are a couple of great talks that happened in ADC this year as well regarding CI/CD. So one would be Jatin Chowdhury's excellent talk on CI/CD for your plugin development, where he essentially gives us a proof of concept of 4 of these build tools. So GitHub Actions, Circle CI, GitLab, Azure Pipelines. And this repository over here is an absolute treasure trove. It's got plenty of examples and plenty of configurations that you can do. So I would highly recommend checking this out. So what else did we have this year? We had a talk by Eleanor Dolph by automating the development of multi-platform products. And she used Azure Pipelines in this, and there wasn't a lot of code examples, but there were great ideas, and there's something else in there that I'm going to talk about later, which could change quite a lot of things which could remove a particular hurdle. Right. So as you can see, there are plenty of options there. So, and there's plenty of other talks from earlier ADCs that talk about this as well. So it's well worth checking it out. So just thinking about generally, how do you differentiate between CI tools? Right. So you can either go for a software as a service, a SaaS option, or a self-hosted option, and that's pretty much where it all boils down to. Do you want a SaaS offering or a self-hosted offering? So what does that mean even? So software as a service is you either pay or subscribe to a service which will give you the software underneath the hood. So GitHub, for example, is a service, is a SaaS software as a service, because it gives you the service of version control. Previously people used to have servers that used to have version control hosted within their organizations. So nobody kind of does that anymore because we have services that offer this tool. So let's see what the advantages of a SaaS offering are. So now you actually don't need to have any hardware or software infrastructure that you need to maintain. Everything is maintained by the provider of this service, and it's easy to get set up and configure. It's quite simple as well. But the disadvantages may be that it may not support all platforms and tools and environments. So some of them may only choose to support Linux and Windows, but not Mac, and some of them might not choose to support certain niche tools. And you don't have a lot of flexibility. You have to choose from one of the tools, or you can perhaps try and run some shell commands, or try to get things that you don't have via tools there. But a lot of them are quite modern, and they offer a lot of generic tools like support for Docker and containers and containerized services and so on. The cost of using such services is generally high, but it's not all that high when you're starting off, but it inflates quite a lot as the business needs grow. And one of the biggest disadvantages here, one of the biggest problems really, is there's no access to hardware or peripherals. Right? So for audio application development, sometimes you need proprietary software that needs to be installed on your computer. Some of the code might not be available using a curl command, for example. For that, you need to actually have the code installed on your computer or the software installed on your computer in your build server to actually make it work. That's one of the problems. The other problem is, as I mentioned, the iLock, right? So you need to be able to plug this in for PACE or AX validation. Sorry, AX code signing, and which in Eleanor's talk, she mentioned that they are able to accomplish this using PACE's new tool for doing the same thing. But you can have the iLock as a cloud. You have to pay for the cloud service for iLock. But they've developed a new tool where you don't really need the proprietary wrap tool essentially to be installed, which is a game changer. And it was news to me. So the hardware, access to hardware for code signing might not be an issue anymore, which we'll have to see. But then there are other code signing mechanisms like with the Windows code signer. So you have extended validation, or is it extended verification? So the EV code signing certificates, they come with something very similar as well. So you need to have a USB dongle of sort with a license actually physically plugged into a peripheral of a computer. And sometimes when you're doing integration tests or end-to-end tests, you want an audio interface connected to your computer, to your build server to actually do the integration tests. It's a very niche use case, but it doesn't give you the flexibility. Software as a service doesn't give you that flexibility essentially. But self-hosted, there's quite a lot of extensibility and flexibility in this. So you control the build server. So you can do whatever you want on it. It's not the same if it goes into the cloud, but then again, there's quite a lot of extensibility in terms of like downloading, using plugins and software that you may not have access to in the SaaS offering. You may have you may have access to hardware and peripherals if you host it yourself. And the disadvantages of this method is it's generally more complicated. It's more time intensive to set up. But once the initial setup is done, it should be easier. But also, since you don't actually control the build server yourself, you need to patch and maintain and update things as necessary, because it's not just the build server itself like that you have to update. You have to update. If you're using it in Windows, you have to update Windows, patch Windows constantly, just make sure that you're not vulnerable. You need to patch the Jenkins or your self-hosted CI as well. And if you're using any plugins, you have to update those as well. And all of that is not really a problem with SaaS offerings. And all the build tools would generally fall into, sometimes they fall in between. So like Circle CI and Travis would offer both software as a service and self-hosted as well. And certain ones like GitHub Actions fall absolutely on the side of software as a service, nothing else. And Jenkins is on this end of the spectrum where it's only self-hosted solution. So why Jenkins at all? Because there's plenty of other things there. So one, it's free and open source, and it's quite easy to install. It's not really hard. The open source and free is quite important for a lot of people, I assume, because you can change the code as you like. You don't need licenses to install it, so you can essentially just use it wherever you want it. Wherever a JVM can run, Jenkins can run. So it can be even embedded processors and smaller embedded CPUs can run Jenkins as well. As a broad plugin ecosystem, there are like 1,000+ plugins there, loads of things. It's one of the oldest CI tools as well, so it's got like a large and active community of users. It supports parallel execution, so there are plenty of executors that can run simultaneously. And also within the build itself, you can have parallel execution. And it supports distributed builds with master slave architecture. And this is incredibly useful when you're running it in the cloud, because you can distribute builds to different to available control and agent nodes. The disadvantages of using Jenkins is basically it's fairly complicated. The pipeline is really clunky. It's not. It's very verbose code that you have to write for pipelines, and and some of the plugins and stuff are quite unmaintained, so they're not used, they're not being developed anymore, and there are plenty of compatibility issues that you might run into if you're using an old plugin versus a new plugin. And it's also really ancient, right? So it's one of the oldest one. I think it's around 15, 20, even 20 years old by now. So there's not first-class support for like the newer tools that are out there, but then you can get them via plugins. But again, it's not, the Jenkins itself doesn't actually support it. Right. Let's. Actually, I'm really slow. This. I thought I'd be here faster than that. But let's look at the general workflow of CI. Right. So you've got your developer machine here, and the first thing you do is let's say it pushes some code into version control. So the code goes into version control, and the build server is on standby. What we'll be doing is the developer machine will be the build server, but let's separate out in this particular architecture. The build server will get notified, or it'll poll the version control and see if there are any changes. If it does recognize any changes, then it'll go ahead and download all the dependencies that it needs, like juice and whatever else that they might need. And then it's going to build it within the build server, and then it's going to notarize and code sign it. And then after that, you can go into like an artifact storage, long-term storage for the artifact itself. And then the last step would be to notify the users, whoever is subscribed or interested in the build succeeding or failing. They can be notified of this. And this would be an example pipeline for building BSD3 and audio init plugins. So there'll be a checkout phase where you notify like the user of a build being starting, and then you check out the code itself. And in the build stage, you'll actually download Juice. If you have to build Juice yourself, you do that, or you can download the Juice, the release version, and you have Producer there. Or if you don't really need Juice at all, you can use CMake and the recursive modules to get the code there and build it by CMake. And you run unit tests on it, and you do, and then you split the execution into like an agent which is running on Windows, and an agent which is running on Mac. And they both do their individual builds, and once they're built, then they're tested. Plugin validation step. You could have other steps here like integration tests and end-to-end tests, but let me just skip that. And after that, there is a package step where you create an installer for each of the operating system, an exe file on Windows or a package file on Mac, and you use sign tool for packaging for signing the signing the Windows executable, and probably product sign and Apple notarization for Apple, for Macs, and then you upload it to S3. And you bump up the build version because your CI build server can actually do this. Every time a build happens, you can bump up the last version, last digit in the version. So it's 1.0.0. So that'd be 1 would be the major version, minor version, build version. So every time a build happens, the build version can be bumped up. And then notify the people who are involved. And this is a concrete pipeline. Obviously, people's companies, their individual needs may differ, but this is what our needs are. So I've got it laid out here. That's pretty. That's a bit hard to swallow because there's a lot of steps there. But what we're going to do today is something like this, right? We'll eliminate all the need for dependencies. So we won't really go into like code signing and all that. I'll show you the pipeline that actually does this, and we can explore a little bit of the concepts on how to do this there. But what we're actually going to be building is try and get rid of all the dependencies, right? So like you may not have Slack, you may not have access to S3, you may not have the sign tools installed. So, but you do have Git, hopefully, and we'll download Juice, we'll build it, we'll download plugin val, we'll run the validation, and then we'll package the applications into exes and packages. Obviously, there won't be code signed, but we'll have something to showcase at the end of this. Right, and we can get started soon enough. And these are the prerequisites. They're just putting it out there. I also put it out in Discord if you had a chance earlier to check it out. I hope you have some of this installed already. Java is quite important at the moment because Jenkins is a Java application, so it's written in Java, so it needs the runtime of the Java virtual machine to be run on. You can either install it via brew on Mac, or the manual steps that I've laid out in Discord. And well, you have Visual Studio 2019 or MS Build command line tools for Windows. I mean, if you've done any plugin development, you'll have all these already. And if you're on a Mac, then you need Xcode command line tools. And there's another little step there. I didn't really want to include this. I was hoping I could get this as part of the build pipeline step itself, but I wasn't able to. So Mac white box packages for Mac, just to build that last step there to create the package. It's fine if you don't have that. It'll just fail in the last step for this, and then you can rectify it by actually installing it. Right. So let's actually get started. Right. And one thing to actually check that you have Java running is you can go into. You can open up the command line and just check if Java is installed by saying Java-version. Mine says it's Java 11. It's one of the requirements for Java in one of the requirements for Jenkins is it's Java 11 and no later than that. That's because Java 11 is the long-term support version of Java. So JDK archives is one of the links that I've sent there. And this is what you need, Java 11. And if you can install that, that'd be great. Right, so let's get started. So one, we can go to Jenkins, download. And we can get the Jenkins installer from here. If you go to the Jenkins page, we've got plenty of options here. And you can definitely use one of these, right? So you can actually just say, if you're on Mac, you can download this. Or if you're on Windows, you can download this. But I'm going to download the generic package, the var application here. That's because we're going to get like a very similar, we're going to get a similar workflow for both Mac and Mac and Linux. So I'm going to use that. Oh my God, my internet is really slow. I'm going to cancel that out because I already have one. Right. So once you download this, you could go and actually run it. And the way to run this would be at the moment it's being downloaded at the downloads folder. I'm going to go there. I'm going to run this command: java-jar jenkins.var. var is essentially a web archive, and Java applications can be embedded within this web archive. Once you run this, Jenkins is essentially a web application server. So there's an application server that boots up as well, and Jenkins as an application sits on top of that, and it exposes it listens to a port. By default, this port is 8080, but you can change that by an option. So you can say --HTTP port in camel case equal to some other port, for example, if there's a conflict with ports. So this one by default will listen to a port 8080, and it'll dump a few things here. So what it's dumping here at the moment is it's saying this is the administrative password to get into Jenkins. you need that for the initial setup, and after that, it'll ask you to create a new user for Jenkins. So let's hold on to that one there. Are there any questions at the moment? Let me check the chat.
Nothing at the moment. Looks like we've answered all the questions so far.
Cool. All right. Now, if you want to open up the Jenkins Jenkins application, like I said, it's listening to port 80. So you can just say localhost. I'm sorry about that. That's Alexa being a little obtrusive. Alexa. Cool. So once we head into once you go into localhost 8080, it'll give us this form essentially, saying unlock Jenkins. And as I said earlier, this is where the password is. So you can just copy that password there. It'll be different for you.
Okay, Akash, there are two questions. Question one is from Yaroslav, and he asks, what is an artifact?
Right. So an artifact would be anything that is the result of a build process. So in the realm of audio development, an artifact could be an executable or a linked library or DLL file or a VST3 file or a components file. So anything that's the result of a build process is an artifact. Does that answer the question?
And what is S3?
Oh, are you seeing it over here? S3?
Yes,
sorry. Oh, yes, of course. Sorry, my bad. Let me just go back to the slide there. This is perhaps what you mentioned there, upload artifact to S3. S3 is actually an Amazon service, which is S3 stands for simple secure storage or something along those lines. It's a place where you can dump things. It's almost like Dropbox if you want. So you upload the artifact, the build artifact, or the packaged installer to S3, which is a long-term storage. Let's continue. Once we continue, we'll ask us to install the suggested plugins there. Let's go ahead and install all the suggested plugins. This may take a little bit of time because my internet at the moment is not great, but hopefully it should install for us fairly soon. Right. In the meantime, while Jenkins is doing its thing, while it's installing all of the things that are required for us, we can go ahead and set up another process, which is the SSH key that we're going to use for accessing GitHub. And also, I'm going to share the link to the repository that we're going to use. So let me share that there. In chat. Great. So I've put the link to the repository on chat. I'm going to put the link to the repository and the slides as well on Discord later on, after the event is done, so people can check that out. So if you could please clone that would be great. So I've already cloned this repository, and it's here, right? So the repository itself contains, it's a simple Juice plugin project. And the things that it has that you might not have seen before are the Jenkins files here. the Jenkins files are responsible for that's where the pipeline goes, and we'll explore that in the next hour. But please check this code, check this repository out into your own system so that we can actually work on it. I would ask you to fork it and try and do it yourself, but like maybe not, perhaps not. Just if you can just check this out. If you could just clone this, that would be great. Next thing we need to do is make sure that we have an SSH key set up. I usually set up SSH key for each machine that I'm working on. So the way to do that would be going into GitHub and then going into settings. And you can go into SSH keys and GPG keys. Like I said, I have a fair few SSH keys here, one for each machine that I'm accessing from. So let's set up a new key. So you can, if you don't know how to set up a key, or if you haven't had a key before, I strongly encourage you to use SSH keys for cloning and stuff like that, because I think GitHub is deprecating the old HTTPS way of doing it. So the instructions are quite clear. So if you go into generate SSH keys instruction, you can see that there's a page here which shows up, generate a new SSH key and add it to the SSH agent. And instructions are quite the same for Windows and Mac. So for the Mac, it's the same. For Windows, it's the same. I'm going to run this command, and I'm going to change the email address, of course, on git bash. So once you run this command, it'll ask me to give me a name of file on the destination where it should be saved. So just remember where you're running this command from. I'm running this command from within the CI plugin demo repository. You can run it from anywhere you want. The ideal place for SSH keys to go would be your user directory and .sh. So in Mac, that would be your user home directory and then .sh. So I'm going to say Jenkins from Windows. You can name it anything. I'm not going to give it any passphrases. So enter. There you go. So that's there'll be a key generated for us. The keys that are generated are an asymmetric key pair. So you have Jenkins from Windows.pub, which is the public key, and the one without the extension is the private key. So I'm going to move them out of the repository because I really need them here somewhere. Maybe not. Right. So what I'm going to do is I'm going to cat. To install this key that we generated, we go back to GitHub in your settings in SSH keys, and you add a new SSH key. You can give the title whatever you want. So I'm going to say Jenkins from Windows. And you need to copy the contents of the public key over here. So I can just say, move back a couple of directories. I don't know if I can cat Jenkins. Sorry. Public key. And this is what I need to copy. And then I paste it here. As you can see, a new public key will be added to GitHub, and you can access it here. So using this public key, I have read and write access to my repository. With your public key, you will have read and write access to your own repositories. And it also says it's never used. You can actually revoke it anytime you need. So if a machine gets compromised or something, you can actually revoke access for a particular key. And I know we're kind of running into the hours mark there, but I'm just going to try and finish the setup, see if it's done. Okay, so you should be at this point of time, it should be over here, and it should have downloaded and installed all the plugins that are necessary. And I'm going to create my first user. You can call it anything you want. Save and continue. And we want to expose the Jenkins URL over here directly at port 8080. Save and finish. And your Jenkins setup is complete. And you can start using Jenkins now. So I'm going to stop here for the time being. Let's take a little bit of a break. Let's take a breather.
Yeah. Before we do that, can I? We have one question. There's a person that said, when I installed Jenkins with the Windows installer, I had to run it as a local system instead of local, as it wouldn't recognize my administrative privileges. Are there any issues running Jenkins as a local system? Then he says the installer says it is not recommended.
Yes, if you're running it as an installer, it'll ask you that question. Yes, and ideally, if you're the administrator of the system, you should have the privileges required to run Jenkins as a service, essentially. So the only thing that's different here is I'm running Jenkins, but if I close this, the Jenkins will shut down. So that it's not going to be recognized anymore. We have to rerun the command again to bring it up. All the Windows application will do is it'll do the exact same thing that I've done, but it'll use it as a service. So it'll run it as a long running service. It can be stopped and restarted every time, and it'll bring it up every time the computer restarts again. So the only the vulnerability of using Jenkins as a root user, because it says it's not recommended, is if you have malicious commands that are run, it could ruin the build server. For example, if you run something like remove directories from program files or Windows directory, if you are the root, you're permitted to do that, and you could absolutely corrupt the build system itself. So as long as you are the only one who's using build server, it's fine. But again, it's not really recommended. Just make sure that nobody else is running weird commands on your system, and you should be fine. So we saw Jenkins here as essentially a desktop web service application, and you want to try and see what Jenkins is doing underneath the hood, like how it's architected. So here's like a very like a 100-foot pole view of what Jenkins is. You've got the Jenkins is essentially running on top. So you have this server, which is your build machine itself, which is your developer machine that you're using. On top of that, since you've installed Java 11, you have something called the Java virtual machine that's running. So all Java applications or Java Java programs, when they're compiled, they could get compiled to something called bytecode. This is not machine code like it would happen in C++, right? So if you compile something, it would get compiled down to machine instructions. So for Java, the whole point of Java was, when it came out, write code once and then you can run it everywhere. So when you compile a Java program, it'll compile to this intermediate stage called bytecode, and the bytecode and the Java virtual machine is responsible for interpreting the bytecode and converting it into machine instructions based on where it's actually being run on. So there is a JVM for Windows, there's JVM for Mac, Linux, different embedded systems have JVMs. So it's responsible for getting that same bytecode and then interpreting it into machine code for that particular machine where it's installed in. So the JVM is a crucial point of contact here. And that's one of the reasons why we don't really use Java to write audio applications, because there's more intermediary steps there in between. And Jenkins as an application itself is, again, like I said, it's a web application server that is bundled with Jenkins. It's called Jetty, and that opens up a port as well, which you can configure. And Jenkins has something called executors, and these are individual pieces of you can have one or more executors or zero or more executors for a Jenkins application, and each executor performs a particular job. So if you have a pipeline, each executor would be responsible for running that pipeline. If you have a pretty beefy system, you can have many number of executors, so it splits up the system resources accordingly, and each executor gets a chunk of the resources of the system. But if you don't have a very beefy system, you might just choose to have one executor. And if you're running in something called a master-slave configuration or a controller-agent configuration, the controller would not do any execution on its own. So its sole responsibility would be to just delegate the tasks away to everything else that is capable of doing. So that's Jenkins for you there. And we saw Jenkins, and if you haven't forgot yet, we have the key. So we dealt with one aspect of the key, which is the public key, and we put the public key into as an entry within SSH keys here. Now with the private key, we pass the private key on to Jenkins, so that we're doing this so that Jenkins will have the ability to contact GitHub and clone repositories or do anything it needs to do over there. So that's the mechanism you provide using SSH keys. So how you do that is you'd go into Jenkins, manage Jenkins, and over here there are plenty of options to there's plenty of configuration options and choices that you can do here. So for example, you can actually install it as a Windows service here, or in a Mac you'd have a Mac service. And then you can manage users. Currently, you are the administrator because you have plenty of users who have limited access or more constrained access. And for adding the credential as for managing credentials, we'll go in here to manage credentials. We'll go into the Jenkins global store, and we'll go into global credentials. And over here, you can add plenty of different types of credentials by just clicking on this, and you can add username, password, GitHub app password. This is sort of I'm not entirely sure what this is. Maybe you can have SSH username with private key. This is what we want. You can have secret files, secret texts, and certificates as well. So let's go with SSH username and private key. The ID that we're going to give for this is going to be a specific one, and you can actually get the ID if you open the cloned repository that we cloned, and if you go into any of the Jenkins files, you'll see that the ID is this Jenkins-2-GitHub. So if this ID has to match that, so we'll go back to this file and we'll explore this a little more. But for now, I just wanted you to show you where this ID is coming from. So it's Jenkins-2-GitHub. Jenkins to GitHub. The description, you can leave it blank. The username would be the username that you use for GitHub. So for example, this is, if I go back to myself, my profile, see, that's my username. So I'm going to copy the username there, pass that in. And I'm going to say enter private key. And I'm going to say add the private key here. So we have the public key and we have the private key. So I'm going to cat the contents of the private key, and I'm going to paste this here. Obviously, that's not a very good idea to do it on a screen share, but don't worry, I'm going to delete it right after using it. So Jenkins from Windows, I'm going to move this file outside the screen share area. Press enter. So I'm going to copy the contents, the whole contents of it. So beginning from begin open SSH private key to all the way down below. So I'm going to copy the contents of that, and then I'm going to paste it here. Right? So this is going to be my private key. Passphrase, we didn't actually provide any passphrase when we're creating this. So let's go ahead and press OK. Now we've got the credentials being embedded into Jenkins. So the Jenkins now has the private key, and GitHub now has the public key. So Jenkins can actually communicate and clone repositories that it needs. It knows what it now has a mechanism to do so. Now, let's go back to the dashboard. And let's explore Jenkins a little more. So as you saw earlier, there was the plugin section where it just downloaded and installed a few common plugins that we usually use. But there are plenty more where that comes from, right? So you can go into manage plugins, and you can see see all the available plugins out there. There's plenty of them. One for Docker, from DBs, for API access, for running parameterized builds, and there's plenty, right? There's thousands of applications here. If you feel like you want something and it's probably already there. So for example, if I want to access something like S3, so I can say something like S3. S3 would be the AWS service. So you can just say S3 publisher. So can use this plugin to publish things to S3. Obviously, you would be able to do this via just calling REST APIs. But then this gives you a little more like an easier way of doing things, a more declarative approach, if you will. Right. Back in Manage Jenkins again, so you can go into configure system, and there's plenty of system configuration options and tools that you can configure as well. So you can say this is my home directory. You can change the home directory as well, and you can say the number of executors is 2. You can change that. Again, and the URL that you want to give is and so on. Let's actually do something useful with this. What we're going to do is let's clone a repository from here. So let's create our first job on Jenkins, and let's enter it as a test job. I don't know, something. And let's select a freestyle project. And let's say okay. Right. So this is where you can actually configure all of the things for what should happen in the build. So these are all the build steps. So in general, you want to say discard old builds. Sure. Okay, let's discard. You don't want to keep older builds. That's fine. So where is the code located? It's source code management. So I'm going to say it's located. It's a Git repository. So I'm going to enter the URL of the repository here. So let's actually use the same repository that we're using. CR plugin demo. I'm going to use the SSH link. So when I'm because we're using SSH keys, instead of using HTTPS links, we'll use SSH this time. We'll go in here and we'll say this is the URL. And then because we have configured the credentials there in the private key section, I'm given the option to choose that. So I'm going to choose this. So if there was a problem, if there was a problem by now, if the credentials were not configured correctly, it would give me it would give me an error saying like I'm not able to reach GitHub, or I'm not able to, these credentials are not valid or something like that. But since there's no errors here, it's just saying it's fine. It should be good to go. And I'm looking to build from the master branch. And there are other advanced options here, but let's just keep it simple. And what are the build triggers, right? So you can actually trigger builds based on things, like you can build it periodically. So every hour or every day, this build can happen. Or you can poll the source code management system to see if there are any changes there. For now, it's just a simple job. I'm not going to do anything. And now the actual build step. What can you do with the source code that you just cloned? Currently, depending on what plugins that you have installed, you have like more options or less options depending on that. Or as you can see, you can actually use execute Windows batch command or execute shell, right? So you can use actual shell commands here to do things. So you can for now, I'm just gonna use a very simple command dir just to list the contents of the directory. If you're using it in sorry, if you're using it in Mac, you would use execute shell instead of execute Windows batch. So in shell, it's the same one would be ls-l or something like that. So the only command that I'm going to be using, our entire build step is just going to be dir, which is going to just display the contents of the directory, just to make sure that the Jenkins as a build server is working correctly. We can add additional build steps if you want, and we're going to expand on this, right? So obviously, we're not just going to display the contents. We're actually going to go ahead and build the artifacts for us. And the post-build steps, we can see that there are, archive the artifacts. You can publish it somewhere. You can send notifications. You can send email notifications if you've configured your SMTP servers stuff. And you can delete the workspace after the build is done. So let's not do any of that. Let's keep it very, very simple now. The only things that we're doing is we're checking out the code, and then we're just displaying what the contents of it are. Let's save this. And let's build it. So I'm just going to say build now. So it's going to pick up one of the executors, and it's going to run the job on top of that. As you can see, it succeeded, and you can say and go and check the console output. In the console output, you can see that this is where the job was built. We'll actually go and explore that place a little more. It was started by the user, and all it did was check out the code, and it displayed what the contents of the code was. So you have your CI plugin demo and your Jenkins files and all of that jazz. I hope you're able to do all of this so far. So if you want to check out the actual place where it's doing all of this, so it will be in the C drive under Jenkins. And over here, you will have a workspace, and this is the test job the new job that we created. And this is what the code, this is the code that was installed. Similarly, on a Mac, this would be in the home directory, and then / Jenkins. Yeah. So this is the directory that Jenkins is installed in, and this is where all the build processes are kept, and the user information is kept. I'll be users / the actual user / .jenkins. Cool. Now we saw that this job, sorry, let's go back to configure this test job. We saw that there were there are build steps here, right? And you can actually go ahead and run ms build here if you want to, like for clone get juice, run ms build, run the packaging tool, and all of that. You could do all of that here. and that would be perfectly fine. And you don't need to have like a pipeline build or like or any of that, and it'll still work. But we're going to go with a different approach called pipeline as build. Pipeline as code. So what it enables us to do is have all of the steps that are required to actually build it, not as a configuration within Jenkins, but as checked in code. So we will write a comprehensive list of instructions that a job needs to do. The job itself won't be configured with anything. It'll be quite simple. It'll just have all the information that it'll have is which repository it needs to look at and which branch it needs to look at. But everything else should be part of the checked in code. And that's one of the concepts called pipeline as code. It is the process of representing an entire build process with a script and storing it within version control alongside the code to be actually built. So one of the biggest advantages of this is, well, there are plenty of advantages, right? So one of the advantages is like the CI plugin, the pipeline itself and the code are stored since they're stored in the same repository, the changes are trackable. People can have pull requests on it, and teams can know exactly what the build steps are and what's happening. And if there are problems with it, the build step can be rolled back to a previous version. And the pipeline itself, let's say you want to change the build server to some other place, you want to migrate the build server somewhere else, or the build server completely failed and it crashed. So if you want to set up a build server from scratch, now the job needs to contain all of the information about how to build. That's a time-consuming and sort of unnecessary process. So, for example, if the CI server goes down, it can quickly be set up again, and none of the actual steps that needs to happen, the build steps need to be defined within the CI server itself. It can be defined within the version control. Now to actually look at the code, and we're going to start with the simplest Jenkins. The simplest pipeline code. Now we already have a few pipeline templates here, and this might look a little intimidating, right? There's a lot of indentation there, and it just may look a little intimidating. But hear me out. It's going to be quite simple once we actually dig into it. So the simplest way to start a pipeline is just let's go back to Jenkins. I'll leave this. Don't really care about that. We can delete the test job if you want, but I'm just going to leave it there. The simplest way to create one is saying, I'm going to say CI plugin demo. I'm going to go into multi-branch pipeline here and press OK. Again, all of the build steps are part of the source control. So we're going to add source control here. And the URL for this is same as what we did earlier. The project repository is the same as what we have, and this is my credentials, and that's it. Just say save, and we've created our first multi-branch pipeline code, job. So what it's going to do is it's going to check, and it's going to say it's found a pipeline script there, and now it's going to run the pipeline script. It's running the pipeline script, and all it's doing is it's checking out the code, starting the pipeline. And it's finished with success. So what did it do? Absolutely nothing. Again, it's just checked out the code. So that's the simplest pipeline we have at the moment, and we'll build on top of that. So let's look at what the pipeline is. This is what it looks like. Stuff before it is just essentially comments. So this is a comment about what it does. And I've defined a couple of variables here. Project name, which is called CI plugin demo. and the Git repository URL, which we already know. There's something called version that's not filled up with anything. And the pipeline itself, I have collapsed it at the moment, so I'm going to expand a little bit at a time. So it starts, all Jenkins pipelines start with something called a pipeline. And it's a declaration of a pipeline. And we have a keyword called agent, and it says any. It just means that run on anything that's available. Any build server it finds that it's available, we can let it run on that. We don't have to specify anything in particular. We'll look at trigger in a little bit. But then we have stages. And the stages are quite simply just stages. So we're going to have each stage, we're going to have 4 stages within this pipeline. The first stage is going to be a checkout stage, and then a build stage, and then a testing stage, and a package stage. And within each one of them, we're going to fill it up with information soon enough as we keep going. That makes sense, right? So it's not too hard if you break it down. So you have a pipeline, and you have plenty of stages within that pipeline. The stages are checkout, build, test, and package. So we write within each of these stages, we write some declaration about what needs to actually happen within that stage. The trigger here just means that this pipeline will be triggered every time there's a change in the code. At the moment, it's saying it's polling the SCM. If you don't recognize this, it's called a cron scheduler. Cron scheduler is just like a weird way of representing timing information. So if I go into, I just type cron visualizer, and I'll go to the first link there. You can see that 5 of the digits represents certain contextual information. So the first one is minutes, hours, days, months, and week, the day of the week. So I'm just going to say random, right? So this particular syntax means that it's at midnight past 5 in August. That's what it means. So let's look at what our cron scheduler is. Paste that in here. See, it just means at every second minute. So what we are trying to say here is trigger this. Look at the poll. Look at the source code. Look at the source code management system, which is GitHub, every 2 minutes. So what it's going to do is it's going to look at GitHub every 2 minutes to see if there's a change. If any change has happened within that 2 minutes, it will build this entire pipeline. It seems like a bit of an overkill, but that's what I've put here at the moment. It's not really. It's sort of like Jenkins pinging GitHub every 2 minutes. Is there a change? Is there a change? Is there a change? If there is nothing, nothing happens. But if there is a change, and if it is a change on the branch that it's looking at, then it will run this entire pipeline. So again, there are a couple of mechanisms for notifying changes. One would be the push here. So you're pushing the poll here, which means that Jenkins is polling or pinging GitHub to see if there are any changes. The other mechanism is GitHub itself will notify Jenkins once a change has happened. So Jenkins is on easy mode, right? It doesn't do anything in that mechanism. But GitHub itself, whenever we push code to it, we can configure something called a webhook, where you can push information to whoever wants to subscribe for this information. You can't do that when a build server is locally published, because GitHub cannot access localhost 8080 because this is not accessible from the public internet, right? It's only accessible from within your computer, within your network at home. So Jenkins, GitHub doesn't know where this is, so you can't. That's not a viable polling strategy. That's not a viable triggering strategy for us. So poll is the only way we can go ahead. Now in stages, we have the first stage, which is a checkout stage. And this is sort of required. And this is pretty much, like I said, the syntax is something like stages, and you have stage within. And there can be several steps within that stage. Right? Kind of makes sense. So you have plenty of stages, and each stage has plenty of steps in it. And the steps within this checkout stage is, one is called clean WS. It just means it cleans the workspace. If something has happened before, we'll wipe out the workspace and then start over clean by checking it out. The second one is this declarative function called checkout. And it does some things here. And the best part is you don't have to remember this. This seems like complicated. It seems slightly complicated to remember, obviously. I don't really know what's happening here. Oh, there's a way of generating snippets for Jenkins files. So let's go back to our job that we just created. And let's go to this within the CI plugin demo, the job that we just created, the pipeline job we created. If you scroll down, you have something called pipeline syntax. This is like a help page. And there's plenty of interesting documents here as well. So you can say declarative online documentation. This is the full comprehensive documentation of how to use pipeline syntax in Jenkins. And there are a couple of different variants of it, something called declarative pipelines and scripted pipelines. We're going to use a combination of the both. And yeah, so there's more references here. These are steps and what kind of steps that you can have, and so on. The one thing that's interesting here is called the snippet generator. And you can say, I want to clean workspace or delete workspace when built. And I'm just going to say, generate the pipeline script. And it'll give you the pipeline script. All you need to do is copy that into your pipeline. Right? Just copying that. So let's say I want to check out the code. And by the way, this is a really comprehensive list. Right? There's a lot here. Like you can write the file. We can access credentials in here. You can use, like a shell script to run something. You can email something. There's plenty of options here, and this grows as and when you update plugins or add more plugins. So what we're interested in is checking out from version control. So check out from version control. I'm going to use from Git. Again, I'm going to pass the same Git URL there. And I'm going to use the credentials. I want to look at changes from master branch. And I'm going to include polling and change log. I don't know that. Say generate pipeline script. And it'll give me this. And that's it. This is what I've copied here. Right? And just formatted it better, of course. But obviously, I've also added some extensions, something else there, credentials, and so on, right? I've made a few things generic, like the URL. And the whole point of this it's going to be a large Jenkins file. The whole point of it is you can reuse this for several projects. So you can hoist out things that are reusable outside, like the project name and the Git URL, Git repo URL. And you can use this entire Jenkins file for some other project. Let's say you have a new plugin project. You just need to copy this Jenkins file into that project and change the name of the project and the Git repo URL, and you're sorted. You now have a full configuration of a pipeline here. I'll get rid of this. So the first stage is quite simple, right? So the checkout stage, we clean the workspace and we check out the code. In the build phase, don't have anything here. I just have in the steps, under steps, I have echo build. So it's just printing out build. And that's precisely what happened in the build step. So if you look at the first build that happened, the checkout stage happened. And if you go down, it says build. It's test. It says package. These are echo commands being executed. Now, we will fill this information, we'll fill this stage with some actual build steps. So we're not going to actually write it because, you know, there's a huge tendency of making mistakes. We don't have a lot of time here either. So I've actually finished writing the whole pipeline script in this file called Jenkins file producer. And there's another file for CMake type projects as well. So you have Jenkins files for a producer type of project, and then you have a Jenkins file for a CMake type project. Go to the producer one. I'm going to copy the build step from here, and then we'll talk about it. I'm going to copy the entire build step from here. Okay. So as before, you have steps, and you have plenty of steps, and I have a directive called script here because I actually want to write some script. Usually, without the script, it's usually a declarative pipeline, but you can actually execute Groovy code in here. Groovy is a language. It's kind of similar to Java. If you want a more complicated pipeline where you want to dynamically assign variables and so on, then you have to put all of that within the script tag. So I'm saying, if it's not a Unix system, then do this. Otherwise, do this. Ideally, you should actually check for Windows for Mac as well, because if it's not Unix, then it's Windows. Then if it is Unix, it could be Unix or Mac. But at the moment, I've ignored that check. So if it is not Unix, meaning if it's Windows, then I'm going to echo out building plugin for Windows, and I'm going to run these commands as a batch script. All I'm going to do is this, which is getting juice. So it's going to get the latest juice of the Windows variant and as a zip file. And then we're going to extract the zip file. And then we're going to go, once it's extracted, it'll be available as juice/producer. I'm going to go to producer. I'm going to say set global search path as to Windows. And I'm going to, the modules are already checked in. So I'm going to define all of that. And to actually get the builds folder where you have system specific project files, you have to resave. You have to save the project essentially. So you trigger the command, so producer.exe, and resave and the project name .juicer. So once it's saved, there's a new folder called builds that's created, and you go into Visual Studio 2019. And in Mac, you will actually go into build/Mac OS X. And then this is where the actual build step happens. And it's just a single line. What we used to do before was essentially, right? So we used to get the Jenkins project, and you can see that there's nothing here. Sorry, I keep doing that. So there's installer juice source. What we used to do is you open producer and we save this project. Once we save it, you see that a builds folder got created, and inside was a Mac OS X and Visual Studio 2019 based on what the exporters we have selected here are. It's exactly the same, but via command line, right? So all we did was we downloaded producer and we said resave the project. Once we did that, we got access to the builds folder. We go in here, and our usual way of running this plugin would be going into CI plugin demo.sln folder, the actual source folder. What would we set here, right? So we'd set a few different things. We would make sure that the target is the VST3 target. And we make sure that the release configuration is checked on, and then we run it, right? That's all we did. So we make sure that it's in release mode for the configuration, and the target what is this called again? Yes, the startup project is set to the VST3 target, and then we just press OK. It's exactly what we're doing here. We just single command. We don't have to open up Visual Studio or anything. All you need is MS build. MS build is like is underneath the hood. Visual Studio uses that to do the building. So let's see what that is. So you set ms build to something there. If you've installed it correctly, then it should be available in this particular folder. And you're saying ms build, the project name asset.sln file, and you're setting the project, the Visual Studio project to 16, which means that's 2019. And then you're setting the configuration to release, and you're setting the platform to x64, and preferred tool architecture is x64 as well. And that's it. And you run this command, and it'll start building. And then all I'm doing next is copying the VST3 file that it generates to an installer location here, installer directory that I have. And after that, I am querying what the version of this is, of the plugin is. So this is this looks slightly complicated, but we need to have a variable here, and the variable is set to the output of this command. So the output of this command is producer get version from this particular user file. So it'll give you the version. So, and that's saved within the version script and into version. So all we're doing here is downloading juice, getting the producer.exe file, and saving that, saving the project, and then actually building it and copying the VST3 to some other folder and getting the version from it. It's quite similar in Mac as well. So all you're doing is downloading this, and instead the only step that changes is we're using Xcode build with a release configuration and with all scheme. You can use this scheme instead of all. We can be VST3 and AU separately. But yeah, well, there you go. And then you're copying the VST3 file and the AU file to a particular location.
We have a quick question. Akash.
Yes.
Yaroslav asks, can you get those project name and repo URL variables from external sources, for example, external files, instead of manually changing the values after copying the pipeline file to a new project?
So you mean to say, can this project name variable? Sorry, could you repeat that again? Because what I heard was if you copy this entire pipeline file to a different project, you want it to work there as well, right? With minimal changes. I'm guessing that's the idea here.
He says the variables at the very top of the file.
Yeah. So the variables at the very top of the file, I have defined it here, but you can feed this variable through something else, like through Ansible or Puppet or something like that. So I've defined it here because it's quite simple, because the job just needs to look at the Jenkins file and it'll have all the information there. If not, you can have a job feed in the variables as well. So you can go in here and say, you can view configuration. You can say that it's a parameterized project somewhere. Not entirely sure now. Yeah, so this project is parameterized, right? So if we enable this parameterization, you can pass in parameters to the job that's being made. But I feel this is a simple approach, because you can just define the variables that you need. That these are the only things that are going to change from different projects. As long as the pipeline is the same, the checkout, build, test, and the package stages are going to be the same. It'll pretty much be the same for any other pipeline, any other plugin project as well. So the only thing that would need to change is the variables on top. Again, there's another level of abstraction that you can go. You can have the Jenkins file as a separate repository, and each project will actually get the Jenkins file from that particular repository and do it. So if you, for example, if the pipeline step has to change for all of them, then you don't need to go individually to each project and change them. But the problem then again is like it's over abstraction, right? So let's say a single project now needs to have a new target. Let's say it needs to also have the execute, like the standalone application, or it needs to have an AIX plugin, for example. Then it needs to have its own, or you need to have like 2 different Jenkins files in the Jenkins file repository. So that's the problem with over abstraction. But I feel there's like a delicate balance that you can do, where if the pipeline remains, if each project would need to maintain its own pipeline, but also want to have some sort of stability between two different projects, you can just have the pipeline the same, and you can hoist out the variables that it requires outside, and you can do it like that. But I'd love some thoughts on like how else we can make it more generic, right? Because of course there is the problem of, let's say you want to change something and it'll change across, you'll have to make the change across all of the projects as well. But hopefully, but then again, if you want to change something in just one of them, you can easily do it, right? You don't have to break every other pipeline if you do that change. Potentially break. Cool. I hope that answered the question. And we're running out of time as well. I thought I was going to underrun and not have enough time. Cool. Right. So that's the build step. Let's look at the testing step. The test step again is empty at the moment, and I'm going to copy that from the Jenkins file producer again. That's the test stage. It's the same thing, right? So you got the same stage, steps, script, declarations here, and you're saying validating a plugin. And if it's a Windows machine, then I'm going to run a batch script saying I'm going to get plugin val. If you don't know what plugin val is, you should really check it out. You should check out the 2018 ADC chat by Dave Rowland. So that's the talk there, where he talks about something called plugin val that he has developed for. What is he a part of?
Traction.
That's right. Thanks, Josh, for helping me out there. So he's developed a plugin val for Traction, and it's a pretty amazing tool for quickly validating if the it's a plugin validator tool, like a very. So it's not going to validate anything specific to your plugin, but it'll just make sure that it doesn't break for different buffer sizes and buffer channel configurations and all of that. So it's pretty good. So all I'm doing that is getting the latest version of plugin val, unzipping it, and then just running plugin val, right, on the particular VSD file that is there. Same thing for Mac as well. I'm gonna get the latest Mac plugin val, unzip it, and then run the validate on that particular VSD3 file. And in the last step, which is the package step, I'm gonna get rid of the branch, showing something else there. Is that right? Yeah. In the package step, for Windows, we're gonna get this software called Eno Setup, and this is essentially a software that we use for converting some artifacts into like an exe file. And I'm going to run Eno Setup over here on installer script. The installer script is placed here. So all the installer scripts are placed under installer. You have Mac installers and Windows installers. And in the Windows one, you have a little README file on how it actually works. But this is the actual code. It's quite simple, actually. You're saying what the name of the file is, and in the end, you're just going to create a new executable file based on some information here. And that's an executable file from the VSD3 file. So only the VSD3 file will be in it. Simple installer. Similarly, on Mac, we're going to use something called packages build, and this is a command that's available when you download something called white box packages. This particular software, which is used for creating PKG files. Right. Now I'm going to save this. Hopefully I haven't messed this up. What else am I going to do? I'm going to say, once I save this, I'm also going to bump up the version, the build version, just for the crack of it. So I've got the CMake list file. I'm going to change it to from version 1.0.2 to 2. And in the ProJuicer file itself, I'm going to change it to version 1.0.2. Now you can't actually publish this commit back into the repository because it's not your repository. You could have done it if you had a forked it, but I'm just going to do it right on my machine, and hopefully when I do this, it should pick up the change. So what I'm going to do is I've changed a few things. Right, I've actually put a few steps here: the build step, the test step, the package step. They've filled it up with information on how to build it. And I'm going to push the changes that we have done back into the repository. Now, what should ideally happen is our build server, which is Jenkins, still doing its thing, still active. It should notice that there's a change happened it should notice a change taking place within the Git repository, and it should trigger a build on its own. And if you've followed along with me as well, it should trigger a build on your Jenkins machine, on your Jenkins instance as well. So let's hope for the best. Sorry. I'm going to plugins. Okay, these are the three files that I've modified. I'm going to commit with a message saying bump up version to 1.0.2 with that, and push those changes out. Right. Now we are back in here. We also saw that the poll notifications happen every 2 minutes. So we can actually see that if you go in here to the master branch, you can go, it's already started. You see, you can also check the poll logging here. You can see that the poll was done at 3:52 p.m., which is the current time at the moment, and it saw that there was a change. Since found one remote head, latest remote revision is something changes found, and because it found the changes, it's creating another build. So this time it's not 153 milliseconds because you actually have MS build has to actually do some work here. So this is going to go ahead and build it for us, and then test through plugin validator, and then it'll package it for us. And we'll take a little bit of a breather, and then we'll come back and we'll see that it's being built. We'll hopefully have seen it built fully by then. We can see that the package step, all of the pipeline steps are finished. And as you can see, the build step took probably the longest, as expected, because the compilation step is fairly intensive. But in the end, you can see we can go to where the job is configured to be built at. Let's see, C drive, Jenkins, workspaces. And this is the workspace. And if I go into installer, Windows output, this is where the installer is built. So the CI plugin demo. As you can see, it'll give me an error saying its publisher is unknown and all that. I'm going to say yes, because we haven't actually notarized the signed or any of that. If it's finished. Oh, that's great. Oh, confidential material. And there you go. That's the little tiny plugin. It's still saying, that was built there. It's actually picking it up from somewhere else, but that's fine. It's great. So we've got the build pipeline set up here, and we've proved that whenever new changes happen, it goes through. It gets picked up by our build server, and it does all the things that it's supposed to do. But what I did there was a bit of heresy, right? You're not. What I did there was commit changes and push changes directly to master, and that's just bad practice, of course. And you want to have different pipelines for different branches. So you want to say that for if changes were to go into develop, for example, there was a branch called develop, it wouldn't actually go and package the build or anything like that. It would just stop at some place. And only when changes go into master, after everything's pull requested and approved, only then would it actually go into the packaging step and the deploy step and so on. So we can have a couple of branching strategies, right? So here's what we would potentially want. We want to say like, hey, on the master branch, you want to check out, build, test, package, and deploy. But on the develop branch or any other branch that is a development branch and not any like a transient branch, you want to have check out, build, and test only, and you don't want to package and deploy. A simple way you can change that is to annotate this particular the declaration here saying when branch is master, then do the package step, right? So it would just be, it's a very simple change. We go into package here, and this step will only be carried out when branch is master. And you can make this, you can have variables being passed in here and whatnot. Again, all of this is, it seems a little unintuitive in the sense that where can I learn this? It seems like there's a bit of a curve, a learning curve to this, but it's all very well documented in the documentation that I've showed earlier. So if you can access the documentation by just going in here and going to pipeline syntax and all the documentations here, declarative volume documentation. Yeah, that's great. So that's all it is. And now let's look at a strategy of building that we can leverage within the cloud. What we have noticed so far is Jenkins is now installed on our computer, and our computer acts as a build server. Or there is the Jenkins accesses the resources of the instance, which it's running on top of, which is our machine. What we want to try and do is separate Jenkins outside the actual instances that are going to build for us. So we can have Jenkins running as an always-on sort of device somewhere else, and only when there's a requirement, it'll bring instances up and it'll build on top of them. So you don't need to have Jenkins running on some beefy machine because it compile lots of compilation steps and all that. You can have it on like a very small instance, a tiny instance somewhere, and it should just trigger builds on some other instance, some other compute platform. And we can do that via the branching model or the distributed build model that Jenkins has. So it's sort of like this. So Jenkins essentially has a master slave model or a controller agent model that's built into it. And you have your master here, and that's your Jenkins. And you can see that I haven't put these little icons there. These are icons for executors. So master itself is not responsible for executing on its own and on the instance that it's running on. It is not. The master is just an orchestrator, essentially. It goes ahead and finds an available agent that is free an executor that is free within that agent, and then pushes the job away and delegates the responsibility of building that job over to an agent which is free. And the agent then can be placed anywhere, right? So it can be in a Windows machine, or it can be in a Linux machine or a Mac machine. The agents are completely separated out from the master. The master you can feed all the configuration information, the credentials, and the certificates, and anything else that you want in one centralized location, which is the master. And this is the only one that you're exposing to your company as well, like people who wants to access the instructions and maybe change configuration and stuff like that. And the agents, the slaves, will be completely locked away, and Jenkins is the only one who would have control over them. Of course, you can turn them on or off later on if you want yourself, but that's the model, how it works. So again, you can make the master publicly accessible to people within your organization. You can have consolidated reports directly from the master from what happens within the agents. And you can have it hosted on like a tiny little low-powered instance, because it's not actually responsible for building in its own instance. It's responsible only for delegating the responsibility out of it. So we're going to try and leverage this model within the cloud. But we want to ask ourselves really why we want to leverage the cloud at all. And again, we want to try and distribute the builds, because we're not just responsible. We're just not interested in building on one platform. We want to build on Mac, Linux, and Windows as well. So we need instances essentially. We can't trigger each one of these builds in each one of the instances, because then you have to look at each one of those instances and consolidate the reports from each one of them and say, okay, it's working there, it's not working there, it's working there. But rather, if you have a centralized place for where everything's all of the reports are consolidated in, it's better essentially. And why else would we want to leverage the cloud? Because you can have high availability and high scalability within the cloud. Scalability would be, let's say there is nothing happening, so there are no developers. The developers are out today. There's not going to be any commits being pushed into repositories. So at this point of time, having a build server sitting somewhere in a rack is sort of expensive, right? So you're paying for it being on all the time. You're paying for builds for the server itself. But with scalability model, with this particular model, the controller will only trigger the agent, or it'll actually bring up the agent from scratch and then execute the builds on top of it. And after it's done building, it'll go down. The agent will get torn down, and you don't have to pay for instances where you don't. You only have to pay as you go, essentially, in the cloud. A lot of models exist, not a lot of payment models exist. But pay as you go is like a very commonly used one for Linux and Windows instances. So you only pay for however long the instances are up, and not for the allocation of the instance itself. And it's highly available because you can keep it always on. If something goes down, if it's configured right, it'll come back on and it'll start up itself. There's easy disaster recovery, so it's very easy to just, if you have infrastructure as code built in, you can just run Terraform or something similar in cloud. There's something very similar in AWS that you use. Terraform is cloud agnostic. So infrastructure as code, as in you declare what infrastructure has to be brought out and what the shell scripts has to be run in each of those instances beforehand. And if something happens, you can just run the script again, the Terraform script, and it'll just build out the instances as you need. And again, you can, if there are a lot of people making changes in your code base, and there are plenty of instances that need to go up, you can scale it. You can say you can put a cap on the number of instances that should come up, and you can sort of control it. You can have fine control over like how much resources you want to allocate. And these resources can be really bulky, right? So you can have like incredibly beefy machines, like 32 core machines with loads of RAM and CPU power. And because they're only up and running for a little while till the builds are done, you don't have to pay for a lot. You don't have to pay a lot of money for them. And there's the added encryption security of like the instances out there. You can finally control. There's fine control of the security itself, like who can access the instance, which services can access the instance. There's something similar in all cloud platforms, but in AWS it's called IAM, Identity and the Access Management, where you can give fine-grained control to people or services and what they can access. Ideally, it's always like it's an always locked state. You can only open something when you really need to. The disadvantages of going to the cloud, there are plenty. One, if you're self-hosting in the cloud, you come back to the same points that I discussed earlier. You don't have hardware and peripheral access, so you can't actually plug in the plug in USB sticks or like have access to audio drivers, audio interfaces that can be connected. So you come back to the same problem then of what do you do? What do you do if that's your requirement? We'll come to that in a little bit. But the other disadvantages is the need to be wary of the cost associated with it. There are a lot of hidden costs, a lot of things in fine print that can actually, using a certain service is not. You have to be wary because costs can escalate, and there are plenty of ways of checking what the costs would be using cost calculators. And it'll running instances for a couple of months to just check what the pricing would be would also be a good indication of how much you would want to invest in something like this. But the cost can vary quite a lot depending on and also a lot of cloud providers, what they tend to do is they make a lot of the widely accessible ones quite inexpensive, but they make some of the services make really quite expensive. So if you're sort of using both of them together, you'll end up paying quite a lot in the long run. And I've noticed that Mac instances are pretty expensive. One of the reasons is Mac has they have some sort of terms and conditions with how their instances are used. So a lot of the Unix instances, Linux instances, for example, is essentially a virtual machine. So they'll carve out a little part of the actual high-powered instance, and they'll give you a little computing space from that. But Macs, you don't. They're actual Mac minis stored in a server rack somewhere, and you have to associate each one of those Macs to yourself. You can't have virtualized hardware running. You can't have like a slice of the Mac instance. You have to get the full thing. And the model isn't pay as you go; it's pay for 24 hours. So if you're building every day, for instance, this could be really expensive because it's about an hour. It's about $1 or so an hour. It'll end up to $900 or so for a month, which is you can just get a Mac and you can get a Mac Mini and just put it in a server somewhere. That'd be easier. And that's what I've done. So my approach to the being on the cloud is actually a hybrid approach where some of the instances are online, some of them are on my desk, and so it is. And the initial setup can be a bit cumbersome and time consuming. One of the problems is it's quite well documented, but there's a lot to go through, especially in terms of configuration and security. If you haven't worked in an environment where you use AWS and it's the first time, it's going to be a little bit of a learning curve, and it's time consuming as well. And so again, like I said, whatever I'm discussing now is cloud agnostic. So you can run these similar steps on Google Cloud or Azure Cloud or wherever else, but I'm just choosing AWS because I'm used to AWS. we're going to use 3 of the services predominantly. One is called IAM, which is Identity and Access Management. You can manage authentication and authorization for users, for not just for users, but for services. For example, let's say like there's an instance here, there's a controller agent. What does that controller agent have access to? You can cut it down, you can cut short. Let's say there's an agent. What does that have access to? It probably needs access to, for example, S3, which is going to be the storage service. So only those agents will have access to S3 and not the master itself. So you can see how we can sort of have a fine-grained control over like what services and what users need what authorization. And we're going to use something called EC2, which is like the most conventional way of using this. You could use something called ECS, which is a cloud container service, I think. You can use Docker containers with images already built, but this is like the easiest one, right? So this is EC2, meaning Elastic Cloud Compute. You can manage resources and security for instances within. So you can bring up virtualized instances of Windows, Mac, and Linux. And like I said, the S3 is just a storage service. It's similar to Dropbox or so. So this is where I store all the artifacts. Okay, let's look at a little bit of the cloud infrastructure and what we have going. Unfortunately, this part of the talk will just be me rambling along about things on the cloud. But hopefully you'll get a bit of idea about how to configure this yourself. I might skip a few steps, or I just might have missed a few steps because there is a fair bit of configuration involved. But this should be like the general way of doing it. So this is me as a logged in user. I've got as a user. And there's an autoscaler group user that I have that I can use for the autoscaler is essentially used as the user within the Jenkins master. So it has the policies that are required to bring up new instances and the roles. So I've got one role for the slave and one role for the master. And the slave role is essentially I've got only a couple of policies attached to it. And the policy would be the Amazon full S3 full access and read-only access for IAM permissions and roles. Again, their policies can be you can have more fine-grained policies within the S3 itself. You can say only write to a bucket and not delete from anything. So if you want more fine-grained control, you can get it, but it just becomes a little more trickier to do. And a little more a trial and error as well. And once you've got the roles and the roles and some of the policies attached to these roles, you can actually look at the instances that are running. I'm going to go into the EC2 console. And at the moment, I have two instances running. One is called the Jenkins controller, and this is the master node. And this is running if I give it more information here. This is running something called a T2 micro instance. And this is an incredibly low powered instance, right? So there's nothing in there. And also, if you make the controller on AWS using an T2 micro instance, this is free to use for a year. So this micro instance, and if you've got a brand new AWS account, you can use the micro instance as a controller node for free for 1 full year. And you don't have to pay for it at all. And you can see that it's attached to a role called the master role here. Let's see if you can see what instance it's running on. Yeah, so the platform that it's running on is a Linux instance. It doesn't matter what platform it needs to run on. So I'm just choosing Linux because it's simple. because the execution of the build execution doesn't have to take place within the controller. So it doesn't matter what the platform is. But for the actual build service, like this one here, which is an EC2 Jenkins Windows slave node, it needs to be quite large instances. It doesn't have to be large, but if you want fast build times, you need to have it slightly larger than micro. So this one is a T2 large. It's a slightly more bulkier instance. Let's see if there's any. Let's see if there's any information about performance. Sorry, I don't think I can see performance of these instances here. There's the performance statistics of these, but they're beefy machines. The only reason it's running at the moment is I've asked it to run, right? So I've brought this instance up just so I can show you. But ideally, this instance will not be running at all. It'll just be it'll only come up when there is a need for it. And right. And now that I'm actually in here, I can show you what the instance looks like. So if you go into security for the instance, so I've set up a couple of inbound rules. The inbound rules, like who can access the machine, is only via RDP. You can only access this port is the 3389 is an RDP port, a remote desktop port, and you can only access this machine via remote desktop. And the Jenkins master actually accesses it via a different mechanism. And the outbound rules is like all like you can do whatever from within the instance. It can reach out to whatever services it needs, but it's sort of locked down in a sense that you can only RDP into the machine. So I can actually show you what the machine is. So I can go into remote desktop and connect to that instance. And this is the Windows machine that I'm connecting to this instance here. And yeah, so what I'd ideally do is bring up an instance like this and set up everything within it. So you can set up, for example, what would you need in this instance? You need MS build tools. You would need, if there are any certificates, for example, you can get that certificate passed in from the Jenkins controller itself. But the only thing that I really wanted here was the MS build tools. So you can install that and probably set the path variable and all that. And after that, all you need to do is once it's all working correctly, you can say go to images and create image. Once you create an image, it'll store a snapshot of whatever the configuration is for that particular instance into this directory here called AMIs. AMIs stand for Amazon Machine Images, and these are like I said, snapshots of an instance at a particular time. And there's one for the agent and one for the node. And all we need to do is we provide the snapshot, the AMI ID, to the autoscaler group. So we will tell them this is the AMI that needs to bring up that this is the instance. We need to bring up an instance from this particular image, and we need to execute builds on top of that. And after we are done, we shut that instance down. I hope that makes sense. Right. So, like I said, it's quite in the sense of being. It's quite a similar strategy when you're doing Docker images as well, right? So what would happen in Docker is you set up an image, and then you would have Docker run that image as a container, right? So it's very similar, but this is a more manual process of doing the same. And we can set up. Let's look at the Jenkins master control, the interface. So this is the controller, and this is the public IP that it's exposed at. So if I go in here and put ADAT there. Okay, so that's, I should have asked me for, yeah, it should have asked me for authentication, but I think the authentication is already saved somewhere else in the browser cache. So again, I have something very similar there. I have one plugin demo thingy project, and it actually did fail the last time in the Mac build step, but we'll look at that in a little while. But you can see that it's performing these steps for both Windows and Mac as well. And this is the controller. This is the master, and it's not actually building any of these itself. It's delegating the responsibility of building outwards. So we're only seeing a consolidated report of what the instances, what happened within the instances. Now these are the nodes that are available. You can see in build executor status. The master itself is the node that we are on. And then we have a Mac build node and a Windows build node. And these are permanent nodes at the moment. The Mac build node is the one that's sitting on my computer, sitting on my desk at the moment. So I have connected the Mac instance there to the master, which is running on AWS. So it's a bit of a hybrid model, right? So when I see that there are two instances here, there's the controller, then there's the Windows slave. But where's the Mac slave, right? So Mac slave is sitting on my desk. So we're interfacing both cloud resources and on-premise resources with the controller. And that's one of the advantages of being in the cloud. You can actually, if there is a need for certain build instances to be on-premise, just because you need access to the hardware and so on, you can have that flexibility of doing that. I just have the Mac instance on my desk just because it's too expensive to be provisioned here. And also, I wasn't able to actually provision it because there's a quota requirement, and it wasn't satisfied by Amazon. I don't know. I think I did it too late. Right, and this is quite self-explanatory. You can see that there are three nodes again. These two are build nodes, and this is the controller. And you can see like what the response times are, the free spaces, and everything. But how do you actually configure things to come up on the fly? Right? And that's where you go to configure clouds. This is actually not available directly within Jenkins. You'll have to get a plugin to do so. So let's go to Manage Jenkins. Manage plugins. It'll be Amazon EC2. That's the plugin we need. And with that plugin, you'll also get access to publish, to bring up EC2 instances as a build step, for example. So you have more access to the other build steps based on this plugin. But the primary place that we're going to use this is within the nodes configuration within Jenkins. So within here, we're going to say we want to configure clouds. And we've called it slave cluster. So it's a cluster of instances that can come up, and you can set. I'm not sure what that error is. Right, and you can say that you want to have this particular credentials for doing it. So it's a Jenkins user, which has EC2 full access for controlling auto scaling of slave nodes. And all the instances should come up within the EU West 2 region. So all of the instances are region locked within AWS. I think they can communicate between regions, but you can't see instances provisioned within another region when you're in one region. So it's a bit tricky. Things like that can catch you off guard. For example, I'm in EC2 instance. I'm in London, which is EU West. But for example, if I go to Ireland, I'll see none of the instances configured here. So it's all based on the region and where you're in as well. So you can have region-specific instances based on, I guess it's for better latency or so. Where was I? And this is where you actually configure the meat and bones of the instance itself. You want to say, hey, this is the AMI that I want, and it's an EC2 instance of an agent. And this is the AMI ID that we just saved a snapshot of. So this is what we want to bring up. And we can change the instance type as well. So at the moment, it's just set to T2 micro. There are plenty of instance configurations here, all the way from really small instances to really large instances based on different requirements. Let's say you have a big memory requirement, you have a big networking requirement. For example, you want larger throughput, you want a lot of larger bandwidth. These instances are configurable in that way. We just need to know exactly which instance you choose. Also, all the pricing is on the Amazon sheets in their website, so you have to be kind of wary as well what we choose. Again, like each one of those options can actually introduce more costs, so I have to be careful. What's the security groups that we want? We want a security group where we can actually probably try and RDP into it, but nothing else. So that's the kind of security group, and this security group is configured within the EC2 console itself. You can change the remote file system of where Jenkins is going to start building, and this is the user that to log into. We want to say it's a Windows type of instance, and you can specify a certain password. And that's about it, right? So this is how you configure the new cloud, and you can say that you can set the priority. If no instances, so for example, if no other build nodes are available here, it'll provision one from the save custom. Or you can actually go into the Mac node, for example. You can say, this is the permanent node that I have. It says use this node as much as possible. You can change that to only build jobs with the label matching the expression, so that this isn't used. So this instance won't be used unless you actually explicitly ask to be built on that. So if it can't find an available node, it'll try and provision it itself. So that's a bit of the architecture. And then I said the artifacts are published to S3. This is S3. This is what it looks like. And you can go into CI plugin demo, and that's something called the bucket, and that's like a little a drive or directory perhaps. And these are all this is where the build plugins go. So version 1.1, 1.0 is here. You can see 1.1, and these are all signed and notarized as well as 1.1. Now we bumped up the version to 1.2. There should have been a 1.2 there, but obviously it failed for some reason. And we'll look at that later. I'm not entirely sure why it failed, but I'm not going to try and debug it on the call here. So we'll look at that later. If that would have succeeded, it would have created a new one for 1.0.2 here and you can see that they are in fact code signed when you try to run them. Yeah, so when I try to run the file, I can see that it's a verified publisher. That's from the Audio Programmer Limited, and so on. That's the architecture on the cloud. But I just want to, because we don't have a lot of time, I just want to check out the Jenkins file that is used to make this happen. Right? So we had three examples of Jenkins files there. So one called Jenkins file producer, one called CMake, the other one's called cloud. And this particular one is the one that the cloud instances will use when building. So it's quite similar in the sense that we had a checkout stage, a build stage, a test stage, a package stage, a deploy stage this time. And after this, it also posts information to a Slack channel that we have configured. So if I were to open up Slack, obviously I've disabled notifications here. But if I go into Jenkins integration, you can see that this build started when the build started, and if it succeeds, it says started but it failed. You can say that there's a notification that about 3:56 that a build had failed. And the stages there are a little more complex in the sense that because each one of those steps have to be done not just on one build server, but has to be done on both Windows and Mac. So we parallel build them. We use the parallel directive, and in this case, we're assigning the Windows label and the Mac label of the agents. And so whenever it finds an agent with a label tagged Windows or a label tagged Mac, it will build it on those. So we're instead of doing a conditional check if it's a Windows instance or a Mac instance, we're saying we don't really care. We're building on both of them. As long as there is an instance available, as long as there's a build instance available. And the build steps and the test steps are quite similar. Just the package and deploy steps would change a little. And the package step, along with the actual packaging of the application, you sign the installer. In the Mac, you do pretty much the same thing. You call something called install.sh, which is a shell script that I've written for notarization and code signing. But we need credentials, right? So obviously, if you look at the Mac installer, what it's doing is it has a couple of certificates there. These are identifiers of certificates, so it's fine. But you also need username and password and all of that being passed into the shell script. And once it has the username and password, it then does the code signing, it does the package build, it does the product sign, and then it does the actual submission to notarize the application. The notarization step again is a bit of a clumsy step because you have to wait for the notarization to finish, and once your notarization finishes, you get a little. You have to staple the result of the notarization step to the actual package itself. So you have to sort of do a while loop with an attempt to retry every 2 minutes or so, and you can have like a number of retries, it's like 10 retries. Keep checking if the notarization is complete or not. And once it is actually notarized, you staple it. And that's about it, right? So this is code signing and notarization step. But how you access the credentials is the part where Jenkins comes in. So in the package step, you say with credentials, and you give the credentials here, credential ID, and where that credential is bound to. The credential is bound to this particular user variable, and the username is bound to this particular variable, and you pass the username and password in through this. So you're making sure that the source control obviously should not contain the password or any remnants of the password, and it's set up once within the master. So if I go back to the master now and go into manage Jenkins, manage credentials, you can see that there's the Slack token that is required for publishing Slack messages. There's the username and password required for Mac code signing. And that's pretty much how you do it. I'm really sorry. I think I ran through these steps really fast, but I was afraid I wouldn't have enough time. But I am happy to answer any questions that you may have on these steps.